Alright, hi and welcome to another installment of Math Basics with Mr. Besh. Today we dissect the box and whisker graph and we address all the little fundamentals pertaining to this little type of graph. It's a pretty cool graph that you have. I want to give you a couple models or examples because box and whisker graphs can actually have different looks. You see, first pertaining to the box, some of these boxes they can all be different sizes. You can have little tiny boxes like this. You can have really long boxes like this. Some boxes can be upper to the left. Some boxes can be upper to the right. This is where you start out. And all box and whiskers have the whisker part, right? You always have these little lines that go out there. And some of these lines are exactly the same distance or about the same distance. And then what ends up happening is some of these guys, you'll get one that's like really, really long. And sometimes you'll get one that's like short and stubby like that. Okay, you could have two of them that are basically short and stubby. They don't have to both be long. You can have one like really, really long down on this end right here, like I did, and you can have one real short like that. But every box and whisker graph has something special, right? There are 5 points that are always identified in every box and whisker graph. You got a point right there. In every box and whisker graph, no matter how it looks, this point is always the min. It's always the smallest number in your data set. Now, as you travel from left to right, you go over here to the left side of the box. The left side of the box will always be your first quartile. So this is quartile number 1. Now, somewhere in the box, it doesn't have to be in the center, but somewhere in the box, what you're going to see is you're going to see a line coming down through here. And there's another point in the box. And the point inside the box will always be the median. Then, as you keep traveling over to the right side of the box over here is your third quartile, or quartile 3. And then last but not least, this right here, this point is called your max. That's the largest number in your data set. So this is how every single box and whisker is broken down. So if I go to my other examples, there's my min, my first quartile. Remember, your median is somewhere in that box. It has to be in that box. Third quartile, max. Again, min, first quartile, median, third quartile, max. Smallest number in the set, the min, the first quartile, the median, the third quartile, the max. They all work out that way. So now that's how I identify the points. And then based on this, there are a few other things that I can, in fact, do. For instance, the other piece of value that I could find here is I could find the range. See, if I delete some of this down here, get rid of a couple of these guys, I could easily find the range from a box and whisker graph, because the range, what you basically do is you take your max minus your min. So I can do that. So that's one of the things I can do. The other thing that popped up into this section, some students asked about this the other day, and that's a great question as well. There's this other thing. It's referred to as the interquartile range. And basically what this guy is this is your third quartile minus your first quartile. So that's how you find it. Anytime in math you see the word range, it's basically a difference. It's telling you to take two values and take the difference between them. So the range of the data set is the max minus the min, and the interquartile range is the third quartile minus the first quartile. So that's the specifics pertaining to the box and whisker. But let's talk about some other facets about the box and whisker that are kind of neat, right? Another thing about the box and whisker that I want everybody to know is when you have your box and your whisker, another cool thing about the box and whisker graph is that every box and whisker graph breaks your data down into, ready? 25% chunks. 25% chunks. So now when I go through here and I math, so minimum first quartile, median third quartile, max. What happens is when you go from the smallest number in your data set, I didn't want to do that, to the largest number in your data set, this represents 100% of your data. But when you travel on a box and whisker, and when you go, ready? When you go from one point to the next, from left to right, what happens is you start going in 25% chunks. So from the minimum score here to the first quartile, you go 25%. If you were to travel from the minimum to the median, that's 50%. Minimum to the third quartile, that comes out to be 75%. So when you go from one point to the next, no matter what, that's 25% of the data. What that also means is that inside here, your box, since it has two chambers, that's going to be 50%. So every box is represented as 50% and every whisker is represented as 25%. And that's how these guys simply add up to be. Another good question that came in an email was, it said, Mr. Best, one of the things that I don't understand, you tell us that these sections are 25%, but how could this be? For instance, how can this be if I have a box and whisker that looks like this? And this guy has a whisker that looks like that. And this guy has a whisker that looks like this. How on earth is this right here, like you're telling me, 25%? Yet this guy's so much longer, and it's still only 25%. And that is a really, really good question. And the reason why it is what it is because these guys right here, 25% of the data is still there, but the numbers are really close together. And when your numbers are really close together, they don't have that big of a range. And as a result, you get a really, really small section. However, this is still only 25% of your data over here, but the difference is that they are further apart. They're spread further apart. So their range is actually larger when you travel essentially from that third quartile to the max than if you traveled from the minimum to the first quartile. So that's how you get that the disparity on some of these sections are longer than others, but they still represent 25%. All right. So now if we take this and we apply this last little concept to some questions like we had in our homework, it kind of looks like this. All right. So the first part is asking what percent of this graph right here is between 70 and 90. So you go on the number line, you identify in the box and whisker 70, which is right there, and you got 90, which is right there. And now what we're talking about is we're talking about the box. So the box represents 50%. Another interesting question that came up today, I just wanted to clarify this. The number line. All box and whisker graphs have a number line. This number line, as you can see over here from left to right, this is not the data in the data set. In a box and whisker, we don't know all the numbers. This is just a generic number line so that we can easily identify the places that are on this box and whisker. For instance, so I can easily identify this point and this point and this point and this point and this point. I wouldn't be able to tell what they are numerically unless I had a number line like this that would give me the values. So see, it can come right down here. The number line makes this real easy to translate and be able to use this to determine some of my data. So then if I come down here and I gotta say what's the median, remember the median is in the box. Now it doesn't always have to be in the center, but it'll always be inside that box. And last but not least, the third one here, and I like these questions where they ask you, this one here is referring to is a difference. So you now with the difference, you're going to be subtracting, okay? And they're telling you the first quartile, well, the first quartile is going to be 70 right here. So we're going to take 70 minus, and then what they want us to do is the range of the graph. So the range, remember, when you're doing the range, you're taking the largest number in the data set, which is 100, and you're subtracting the smallest number in the data set, which is 55. Notice 50 is not the smallest number. 50 is not part of my graph. 55 is the smallest number. So when I take 100 and I subtract 55 from that, I end up getting 45 here. And then my answer to this question comes out to be nicely 25. So this, ladies and gentlemen, this is essentially how you read and translate box and whisker graphs and their breakdown and all the little ins and outs about them. I hope you found this both helpful and informative.